Hello guys! Welcome to 90 Plus India's first animated live tuition. Are my kids here? Hi, hello. Yes, I can see some red hearts here. Perfect. Yes. So, hello food culture. Yes, hi. You had your dinner? Yes or no? Yes, hi. Yes, hi. All right. Okay, very good. So, today we are going to discuss some important questions. Okay, a total of about 16 questions. Okay, from matter in our surroundings. All right, and ഈ 16 question ഉണ്ട്. Yes. ഈ 16 question ഉണ്ട്. We are going to completely cover the important topics, okay, from this chapter, matter in our surroundings. Okay, so shall we start? Shall we start the section? Can you give me some hearts? Can we get some hearts in the comment box? Then I'll start. Yes. Okay, all right. So, we've already studied this chapter. Yes, thank you so much. Yes, we've already studied this chapter. So, you should answer the questions, okay? You should answer the questions. So, shall we start? Here you go. The first question. A diver is able to cut through water in a swimming pool. The property shown by the matter is... And here's your options. What do you think? Option A, the particles are of very small size. The particles of matter have space between them. Option C, the particles are in solid state. And the last option, the particles have no space between them. What do you think the answer is? A, B, C or D? A diver is able to cut through water. What do you think the answer is? Let me see who's the first one. Yes, hi. Yes, very good. The correct option is option B. See, instead of like typing the entire option, you can just type the option, okay? So that will be easier for you as well, right? Yes, you're right, okay? The particles of matter have space between them. So, yes, very good. Yes, I can see. Yes, hi, yes. Okay, so we already discussed the characteristics of matter, particles of matter. Sorry. So, what were the properties? The particles of matter are very small or tiny. Right. What was the second characteristic? The particles of matter have what? They have space between them. Yes, they have space between them. Then, these particles are in a state of what? In a state of continuous motion. Okay. They are continuously moving. And what was the last one? The particles of matter can attract each other, right? They can attract each other. These are the characteristics of particles of matter. Do you remember them? Yes, right? Yes, all right. So, shall we move on to the second question? Yes. Second question is, which of the following represents the correct arrangement of substance arranged in their increasing order of forces of attraction between the particles? They've asked for the increasing order of force of attraction. Yes. So, what do you think the correct answer is? So, before going into the correct answer, I want you to remember, when it comes to force of attraction, which state has the largest force of attraction, maximum force of attraction? Solids, right? Yes, then come liquids and the least in gases. Okay, So they have asked for the increasing order. Okay, increasing order. Now look at the options. Now look at the options and tell me which is the correct one. Okay, we already have the answers in the comment box. Yes, very good, very good. It's option C. Okay, oxygen. Oxygen is a gas, right? Oxygen is a gas. What about water? Water is liquid, right? It's a liquid. And sugar. Sugar is solid. It's a solid. So they've asked for the increasing order. Increasing order means small to big, right? So it will be oxygen, then water, and last sugar. Yes, very good, very good, very good. All of you are commenting. I'm so happy. Yes. So shall we see the third question? Here you go, third question. Fluids have a unique property of flowing. Okay. Which of the following statements is correct in this respect? Okay, let's see the options in detail. Option A, only gases behave like fluids. Gas matre fluids side behavior. Option B, both gases and solids behave like fluids. Okay. Gases and solids and fluids side behavior. Third option, both gases and liquids behave like fluids. Gases and liquids, they behave like fluids. And option D, only liquids are fluids. I can see some mixed answers in the comment box. C and D. Majority C, and also I can see some D options. Liquids മാത്രമാണോ fluids ആയിട്ട് consider in science? Okay, so I'm going with the majority. Majority C, its answer is C. Okay. Okay. In science, both gases and liquids behave like fluids. Okay. But it's option C. Liquids matramalla fluids. Oh, that's okay. That's okay. Okay. Liquids matramalla fluids. Both gases and liquids behave like fluids. Okay, is it clear? Both gases, fluids, both gases and liquid should come to your mind. Okay? Yes. Perfect. Now let's move on to the fourth question. This is an important question. Okay? Repeated question. This is very, very important. Yes. During summer, water kept in an earthen pot becomes cool because of the phenomenon of option A, osmosis, transpiration, evaporation, diffusion. Yes, yes, before the options, yes, I'm so happy. Very good, very good. It is evaporation. Okay. Okay, yes. Now, if you have seen earthen pots, okay, earthen pots are they have some tiny holes in it. Okay, these holes, what happens? The water continuously seeps into these pores. Okay, they will evaporate. Okay, our surroundings energy absorb, they will evaporate. So when they absorb energy, they will make the nearby surroundings cool. Okay, evaporation causes cooling. Okay, so which is the phenomena? It is evaporation. Is it clear? Alright, perfect. Now, let's see the next question. Next is an assertion and reason type question. Okay, so please don't get confused with the options. Okay, read the assertion and reason carefully and then try to answer. Okay, yes, what is assertion here? Smell of burning incense stick spreads all around due to diffusion of its fumes into air. Okay. Now, what's an incense stick? Chandanatiri, agarbattis, right? Yes. Now, what is the reason? Increased temperature results in increased kinetic energy of the particles. Okay. Yes. Now tell me, what will be the correct option? Assertion എന്താ പറയുന്നത്? Smell of burning incense sticks spreads all around due to diffusion. ഇതിന്റെ reason എന്താ പറയുന്നത്? Increased temperature increases the kinetic energy of the particles. അതുകൊണ്ടാണ് പെട്ടെന്ന് എന്ത് ചെയ്യുന്നത്? Incense stick the smell പെട്ടെന്ന് അത് diffuse ആവുന്നത്. What do you think? Yes. First right answer vannu. Yes. I'm getting some wrong answers as well. Why? Read the assertion and reason carefully and then answer. Very good. Okay, so majority they are saying option A and you're correct. It's option A. Why? What is diffusion? Let me ask, what is diffusion? Diffusion is the intermixing of particles of two different types of matter, right? On their own. Okay. Appo incense stick, what happens? Incense stick നമ്മൾ light ചെയ്യുന്ന സമയത്ത് കത്തിക്കുന്ന സമയത്ത് what happens? Incense stick ലുള്ള fume air നേട്ട് they are diffusing on their own, right? Yes. And temperature കൂടുമ്പോൾ എന്ത് സംഭവിക്കും to diffusion? Diffusion increases with increase in temperature. Okay. Diffusion എന്ത് ചെയ്യും? Temperature കൂടുമ്പോൾ diffusion also increases. Why? Kinetic energy of the particles will increase. Kinetic energy of the particles increase ചെയ്ത് എന്ത് സംഭവിക്കും? പെട്ടെന്ന് അവർ മൂവ് ചെയ്യും അല്ലേ? They will move really fast. Okay. So assertion is correct. Reason is also correct and the reason is the correct explanation for assertion. Okay. Yes. So the option will be A. Okay. Yes. Let's move on to the next question. Next question എന്താ? Gas exerts pressure on the walls of the container. Give reason. Okay. Gas exerts pressure on the walls of the container. Give reason. What do you think the answer will be? Why do gas exerts pressure on the walls of the container? നമ്മൾ ഒരു കണ്ടെയ്നർ എടുത്തിട്ട് അതിൽ നമ്മൾ കുറച്ച് ഗ്യാസ് ഫില്ല് ചെയ്യാണ്. Okay. So it is saying that, very good. Yes, you're right. It is saying that these gas particles will exert some pressure on the walls of the container. Why? Because in gaseous state, the particles are free to move. Alle? The particles and our force of attraction is very less. They are free to move. But they move in all possible like random directions. Edokka direction la move cheyan patto avarokke ivaru move. Okay. And if you move in a samayathu, what happens? They will collide with each other and also with the walls of the container. Okay. Avaru free aayittu avarku energy kodudille. Kinetic energy is very high for them. So they will move in all possible directions. Okay. So when they move, what happens? They collide with each other. Avaru thammil collide cheyum and also with the walls of the container. Okay. Appo endha? So these particles are force exert on the walls, right? They exert a force. Okay. Yes. അതുകൊണ്ടാണ് നമ്മൾ എന്തെന്ന് പറയുന്നത്? That gas exerts pressure on the walls of the container. Is it clear? See, due to high kinetic energy possessed by the gas, they move at very high speed and also in more like all possible directions. And during their movement, they collide with each other and also with the walls of the container. Yes. And also with the walls of the container. Since there are no intermolecular force of attraction. Okay. There is like it's negligible. So they can move easily. And when they strike the walls, they exert a force. Or force on striking. Okay. This is why it is said that gases exert pressure on the walls. Okay. Is it clear? Can we move to the next question? Yes. All right. Yes. Yes. Convert the following temperatures to Celsius scale. Okay. So, the temperature is given in the Kelvin scale and they've asked to convert it into Celsius scale. I'll give you a minute to do the first question. You don't need a minute. You can do it before that. Let me see who is the first one to answer. Convert 300 Kelvin into Celsius. Degree Celsius scale like convert cheyumbo etrayavu? I'll give you time. Yes, very good. Yes, okay. So, Kelvin scale thannitte when they if they ask us to convert into degree Celsius, what will you do? Kelvin to Celsius, temperature given in Kelvin scale minus 273. Okay, Celsius scale like convert cheyanengil endu cheyanam? Kelvin la temperature minus 273. So what will you get? You will get 300 minus 273. So what is the answer? It is 27. Now don't just write 27. It is 27 degrees Celsius. 27 degree Celsius. Like now I have the answer for the second question as well. Yes, very good. Okay, is it clear? Now do the second one. 573 Kelvin to degrees Celsius. What is the answer? Yes, very good. I'm so happy. 573 minus 273, that is 300 degrees Celsius. Very good, everyone. Yes, perfect. So is it clear? Now, degree Celsius, if they ask us to convert into Kelvin, what will you do? Degree Celsius nammalodu choichittu Kelvin like convert cheyan parnal, what will you do? Celsius to Kelvin. We'll add 273. Yes, very good. Okay, so you know the concept. Perfect. Very good. Yes. Now, 8th question. Suggest a method to liquefy gases. Suggest a method to liquefy gases. We gases liquefy cheyan, we studied some conditions. Okay, we've studied some conditions. Do you remember the condition? Yes. Very good, Jyoti. Very good. Yes. Very good. Okay, you remember everything. Very good. So, if you want to liquefy a gas, okay, what is the condition we have to apply? It is to decrease the temperature. Okay, decrease the temperature and increase the pressure. Okay, low temperature and high pressure. Okay, high pressure, what happens? When we apply high pressure, the particles will become close to each other. Okay, particles and they'll become they'll come close to each other. And when you lower the temperature, what happens? If you reduce the temperature, we have studied that kinetic energy is directly proportional to temperature. Okay, if you lower the temperature, the kinetic energy of the particle will also reduce. Okay, it will also reduce. So, applying high pressure and low temperature helps to what? Helps to liquefy gases. Okay, under these conditions, what happens? The particles will become closer and the kinetic energy also will be very low. So, it is very easy to liquefy the gases under these conditions. Is it clear? Yes, can we move on to the next question, guys? Is it clear now? Alright, yes. Here is your 9th question. Okay, why does our palm feel cold when we put some acetone or perfume on it? നമ്മൾ സാനിറ്റൈസർ ഒക്കെ യൂസ് ചെയ്യുമ്പോൾ കൈ തണുക്കില്ലേ? യെസ്, അതെന്തായിരിക്കും? Why? What do you think? Yes. Very good. You forgot it. Try and recall. Very good. I can see some answers. Yes. Okay. Now these acetones and these perfumes and all, no, they are all volatile liquids. Volatile means they easily vaporizes. Okay. Avaru pettanne easily evaporates. Pettanne avaru evaporating. Okay. Appo nammal korchu acetone. Acetone is nothing but your nail polish remover, alle? ഈ acetone നമ്മൾ കുറച്ച് നമ്മളെ കയ്യിൽ അബ്സോർബ് ചെയ്യുന്ന സമയത്ത്, ലൈക്ക് കയ്യിൽ ഒഴിക്കുന്ന സമയത്ത്, what will they do? They will absorb heat from our palm and also from the surroundings. Okay, and they will evaporate. Okay, അങ്ങനെ അവര് ഹീറ്റ് ബാക്കിയുള്ള സറൗണ്ടിങ്സ് നിന്നും പാമ്പിന്നും ഹീറ്റ് അബ്സോർബ് ചെയ്യില്ലേ? അപ്പൊ അത്രയും ഭാഗം എന്താവും? കുറച്ച് ഭാഗത്ത് ഹീറ്റ് പോവാണ്. അപ്പൊ അത്രയും ഭാഗം എന്താവും? കൂൾ ആവും. Okay, it will become cool. Okay, now acetone and perfumes they are volatile liquids. Volatile liquids means they evaporate very easily. Okay, and these particles will gain energy from the palms and also from the surroundings, and they will evaporate. So what will happen? They will ഇത്ര ഭാഗത്തു നിന്നാണ് നമ്മൾ എനർജി അബ്സോർബ് ചെയ്ത് അത്രയും ഭാഗം കൂൾ ആയിട്ടിരിക്കും. Okay, is it clear? Causing the palm to feel cold, alle? Cool out. Is it clear? We've studied that evaporation causes cooling. Nammal padichadalle? Yes. All right. Yes. Okay, perfect. Now, the 10th question. For any substance, why does the temperature remain constant during the change of state? Okay, this is an important question. For any substance, why does the temperature remain constant during the change of state? Yes. Okay, very good. Appo, take melting point. നമ്മൾ melting point കണ്ടല്ലേ? ടെമ്പറേച്ചർ ഇങ്ങനെ ഇൻക്രീസ് ചെയ്ത് 0 ഡിഗ്രി സെൽഷ്യസ് ആയപ്പോൾ ഐസ് മെൽറ്റ് ആയി. ഐസ് മെൽറ്റ് ചെയ്തിട്ട് പിന്നെ നമ്മൾ ഹീറ്റ് കൊടുക്കുന്നുണ്ട്, ബട്ട് സ്റ്റിൽ ടെമ്പറേച്ചർ 0 ഡിഗ്രി സെൽഷ്യസിൽ തന്നെ നിൽക്കുന്നത് അല്ലേ? ബട്ട് until all the ice has got converted into water, temperature remains constant. പക്ഷെ നമ്മൾ ഹീറ്റ് കൊടുക്കുന്നുണ്ട്. Why is that temperature remaining constant? Very good. നമ്മൾ അപ്പ കൊടുക്കുന്ന ഹീറ്റ് അല്ലേ, that heat is utilized to what? To break the force of attraction between the particles. Okay, force of attraction break ചെയ്യാൻ വേണ്ടിയിട്ടാണ് എന്ത് യൂസ് ചെയ്യുന്നത്? ഈ ഹീറ്റ് യൂസ് ചെയ്യുന്നത്. ഓക്കെ, ഇനി ഈ ഹീറ്റ് നമ്മൾ എന്തെന്ന് പറയും? It is called latent heat. Okay, it is called what? It is called latent heat. And in case of melting point, ഈ ഹീറ്റിനെ നമ്മൾ എന്തെന്ന് പറയും? Latent heat of fusion. Yes, latent means hidden. അത് ആക്ച്വലി അവിടെ ഉണ്ട്. തെർമോമീറ്ററിൽ റൈസ് കാണിച്ചില്ലെങ്കിലും ആ ഹീറ്റ് അവിടെ ഉണ്ട്. ആ ഹീറ്റ് എന്തിനാ ഉപയോഗിക്കുന്നത്? To break the force of attraction and converts its state from one particular state to another. Alright? Okay. Now, boiling point കണ്ടപ്പോൾ ഈ ഹീറ്റിനെ നമ്മൾ എന്തിനാ വിളിച്ചത്? Boiling point കാണുന്ന സമയത്ത് it was called latent heat of vaporization. നമ്മൾ പഠിച്ചില്ലേ? Yes. Clear ആയല്ലോ? Is it clear? Yes. Very good. Yes, latent heat of vaporization. Perfect. Now let's see the next question. Yes, very good. Yes. Why is ice at 273 Kelvin more effective in cooling than water at the same temperature? നമ്മൾ പറഞ്ഞു at 273 Kelvin or 0 degrees Celsius, what will be the physical state of water? Both ice and water can coexist, alle? Aa samayathu namukku ice neyum kaanam, water neyum kaanam. Solid state and liquid state coexist. But ice provides more cooling effect than water at the same temperature. Any idea why? Any idea why? Yes. What ice enna cheyyunnu ariyo? Ice adinte surroundings il ninnu avaru heat absorb cheyum in the form of what? Latent heat of fusion. Okay, latent heat of fusion vadi they absorb what? Absorb heat from the surroundings. Appo heat surroundings il ninnu absorb cheyumbo surroundings ന്റെ ഹീറ്റ് കുറച്ച് absorb ചെയ്തു? ഐസ് absorb ചെയ്തു അല്ലേ? സോ സറൗണ്ടിങ്സ് കൂൾ ആവും. ഓക്കെ, ഇവിടെ വാട്ടർ ആണോ അബ്സോർബ് ചെയ്യുന്നത് ലേറ്റന്റ് ഹീറ്റ് ഓഫ് ഫ്യൂഷൻ വഴി? അല്ല, ഐസ് ആണ് എന്ത് എനർജി അബ്സോർബ് ചെയ്യുന്നത് ഇൻ ദ ഫോം ഓഫ് ലേറ്റന്റ് ഹീറ്റ് ഓഫ് ഫ്യൂഷൻ. അപ്പൊ എന്ത് ചെയ്യും? ഐസ് നിയർ ബൈ സറൗണ്ടിങ്സിന് എന്ത് ചെയ്യും? കൂൾ ആക്കും. ഓക്കെ, യെസ്. Now when ice melts, it absorbs energy equal to latent heat of fusion from the surroundings. Surroundings il ninnu energy absorb cheyana. Appo surroundings il korchu heat poi kayna surroundings cool aville? Yes, adondu namukku endu parayam? So it causes cooling more effectively than whom? Than water at the same temperature. Okay, at the same temperature. Yes. Okay. Now, question number 12. Liquids generally have lower density as compared to solids. Okay. Now, solids have maximum density, then comes liquids. അങ്ങനെയാണ് നമ്മൾ common ആയിട്ട് പറയാറ്. But ice floats on water. ഒരു സാധനം ഫ്ലോട്ട് ചെയ്യണമെങ്കിൽ its density should be less. അപ്പോൾ ഇവിടെ ice, even though it's a solid, it floats on water. ഐസിനേക്കാൾ ഡെൻസിറ്റി ആർക്കുണ്ട്? വാട്ടറിനുണ്ട്. എക്സ്പ്ലെയിൻ വൈ. അതെന്തായിരിക്കും അങ്ങനെ? നമ്മൾ പ്രോപ്പർട്ടീസ് ഒക്കെ പഠിച്ചപ്പോൾ ക്ലിയർ ആയിട്ട് we've studied that solids have higher density compared to liquids. But look, here what happens? Like what happened? Ice is floating on water. Ice has lower density than water. Why? That's an exceptional case, right? Now, yes, I can see the answers. Very good. But before answering, what is density? What is density? Density is mass per unit volume. Density D is equal to M by V. Right? Okay. Now, when volume increases, volume increase ചെയ്യുമ്പോ density will decrease. Okay. Oh, I'll write that clearly. Okay. Okay. Volume increase ചെയ്യുന്ന സമയത്ത് density will decrease. Okay. Is that clear? Now, ice in the case എടുക്കുകയാണെങ്കിൽ ice has a cage-like structure. Okay. Okay. Ice like water solidify ചെയ്ത് ice ആവുന്ന സമയത്ത് it has a lot of spaces between the particles. Okay, it has what? It has got lot of spaces between the particles. And ഈ സ്പേസിലൊക്കെ എയറും കയറിയിരിക്കും. Okay, ഇനി ഈ particles തമ്മിലുള്ള space ഇല്ലേ, it is even like it's greater when compared to the particles, like space between the particles of water. വാട്ടറിലെ പാർട്ടിക്കിൾസിന്റെ സ്പേസിനേക്കാൾ കൂടുതൽ സ്പേസ് ഉണ്ട് ആർക്ക്? ഐസിന്റെ പാർട്ടിക്കിൾസ് തമ്മിൽ. ഓക്കെ, അപ്പൊ അവിടെ വോളിയം ഇൻക്രീസ് ചെയ്യല്ലേ? ഓക്കെ, അപ്പൊ ആക്ച്വലി ഐസിന് വോളിയം കൂടുതലായിരിക്കും ആസ് കമ്പയർഡ് ടു വാട്ട്? ആസ് കമ്പയർഡ് ടു പാർട്ടിക്കിൾസ് ഓഫ് ലൈക്ക് സ്പേസ് ബിറ്റ്വീൻ ദ പാർട്ടിക്കിൾസ് ഓഫ് വാട്ടർ. ഓക്കെ, വാട്ടർ അതുകൊണ്ട് എന്ത് ചെയ്യും? കുറെ ഫ്രീ സ്പേസ് ഉള്ളതുകൊണ്ട് ഡെൻസിറ്റി കുറവാകും. ഓക്കെ, they will float on water. Okay, yes. All right, so കുറച്ചുകൂടി zoom. Yes, all right, perfect. So is it clear? Is it clear? Can I change this slide and go to the next question? Yes, perfect. Here you go. Why does a dessert cooler cool better on a hot, dry day? നമ്മുടെ കൂളറൊക്കെ അല്ലേ, കൂളർ നല്ല അടിപൊളിയായിട്ട് കൂൾ ചെയ്യുന്നത് എപ്പോഴാണെന്നറിയോ? ഓൺ എ ഹോട്ട് ഡ്രൈ ഡേ. വൈ? ഇതിന് ആൻസർ പറയണമെങ്കിൽ യു ഷുഡ് നോ ദ പ്രിൻസിപ്പിൾ. ഏത് പ്രിൻസിപ്പിൾ വഴി ഒരു കൂളർ വർക്ക് ചെയ്യുന്നതെന്ന് അറിയാമോ? എനി ഐഡിയ? It works on the principle of evaporation. Okay, actually അവിടെ നടക്കുന്നത് എന്താണ്? അവിടെ നടക്കുന്നത് evaporation ആണ്. So what is the principle? It is evaporation. Now, ഈ question ഒന്ന് ശ്രദ്ധിച്ചു നോക്കിയേ. Hot, dry day. Two keywords. Hot and dry. Now, hot എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്താ? Temperature will be higher. അല്ലേ? Hot means temperature എന്തായിരിക്കും? Temperature will be very high. Okay. Dry എന്തെന്നാ ഇൻഡിക്കേറ്റ് ചെയ്യുന്നേ? Dry എന്ന് പറയുമ്പോൾ എന്താ? അവിടെ humidity will be less. Dry ആണ് atmosphere. അവിടെ water vapors ഒന്നുമില്ല. It's dry. Yes, that means humidity will be less. Okay. അപ്പോൾ temperature high, humidity less. ഈ രണ്ട് കണ്ടീഷനും എന്താണ്? ഇവാപ്പറേഷൻ ഇൻക്രീസ് ചെയ്യുന്നതാണ് അല്ലേ? ടെമ്പറേച്ചർ കൂടിക്കഴിഞ്ഞു കഴിഞ്ഞാൽ ഇവാപ്പറേഷൻ കൂടും. ഹ്യൂമിഡിറ്റി കുറഞ്ഞു കഴിഞ്ഞു കഴിഞ്ഞാൽ then also evaporation increases. So the rate of evaporation will be very high. അല്ലേ? Yes, these are the factors which increases the rate of evaporation. Evaporation കൂടുമ്പോൾ more effective cooling. Okay. Evaporation കൂടി കഴിഞ്ഞു കഴിഞ്ഞാൽ cooling will be more effective. Is it clear? Yes, on a hot and dry day means temperature will be high, humidity is low. Okay. So the rate of evaporation increases. Is it clear? Yes. Now moving to the next question. What is dry ice and how is it formed? Dry ice എന്ന് വെച്ചാൽ എന്താ? What do you think dry ice is? What do you think dry ice is? You're familiar with dry ice, right? Yes, very good. It is nothing but solid carbon dioxide. Okay. Solid carbon dioxide ആണ് നമ്മൾ എന്തെന്ന് പറയുന്നത്? Dry ice എന്ന് പറയുന്നത്. And ഈ solid dry ice എന്ത് ചെയ്യും? They sublime into gaseous carbon dioxide. Okay. They sublime into gaseous carbon dioxide. Carbon dioxide number CO2 subscript ആയിരിക്കണം കേട്ടോ. Superscript ഇടരുതേ. Yes. Very good. Very good. Okay. Sublime means എന്താ? Sublimation എന്ന് വെച്ചാൽ എന്താ? Solid state നിന്ന് direct gaseous state ലേക്ക് പോകുന്നു. അതിനെയാണ് നമ്മൾ എന്തെന്ന് പറയുന്നത്? Sublimation എന്ന് പറയുന്നത്. Alright. But what is dry ice? It is solid carbon dioxide. Okay. Now, how is it formed? നമ്മൾ ഒരു carbon dioxide gas എടുക്കുക. എന്നിട്ട് അതിനെ എന്ത് ചെയ്യും? compress ചെയ്യും. ഇങ്ങനെ ഹൈ പ്രഷർ കൊടുത്തിട്ട്. Okay. ഹൈ പ്രഷറിലാണ് നമ്മളത് compress ചെയ്ത് സ്റ്റോർ ചെയ്ത് വെച്ചിരിക്കുന്നത്. So, it will get converted into solid. Okay. Solid out. Now, when we slowly decrease the pressure decrease ചെയ്യുന്ന അനുസരിച്ച് it will convert into gaseous form. എന്താണ്? അവരെ gaseous formiലേക്ക് convert ചെയ്യും on decreasing the temperature. But they convert into changes into gaseous form without going into the liquid state. Okay. നിങ്ങൾ കുറച്ചിങ്ങനെ സ്മോക്കിംഗ് എഫക്റ്റ് ഒക്കെ കൊടുക്കാൻ വേണ്ടിയിട്ടൊക്കെ ഡ്രൈ ഐസ് യൂസ് ചെയ്യുന്നില്ലേ? വൈറ്റ് കളർ പുക ഇങ്ങനെ പോകും. Okay. You might have seen that. All right. Yes. So is dry ice clear? Yes. So, yes, solid to guess. You're right. Okay. Now, shall we see the next question, guys? Here you go. Now, this is a higher order question. This is a higher order question. Let me see how many of you will answer this. Okay. A gas tumbler containing hot water. Okay. Hot water is kept in the freezer of a refrigerator. Freezer temperature can go below 0 degrees Celsius. 0 degrees Celsius, that you know. If you could measure the temperature of the content of the tumbler, which of the following graphs would correctly represent the change in its temperature as a function of time? അതായത് നമ്മളൊരു ഗ്ലാസിൻ്റെ ടംബ്ലർ എടുത്തു, ഗ്ലാസ് ടംബ്ലർ എടുത്തിട്ട് അതിൽ കുറച്ച് ചൂടുവെള്ളം വെച്ചു. ഈ ചൂടുവെള്ളം എന്ത് ചെയ്തു? ഫ്രീസറിൽ കൊണ്ടുപോയി വെച്ചു. ഫ്രീസറിൽ വെക്കുന്ന സമയത്ത് എന്താ? ചൂട് പതിയെ 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 കുറഞ്ഞു വരും അല്ലേ? ചൂട് പതിയെ കുറഞ്ഞു വരും. എന്നിട്ട് എന്താ? അവർ മെല്ലെ മെല്ലെ ഈ വാട്ടർ ഐസായിട്ട് കൺവേർട്ട് ചെയ്യും. സ്ലോലി കൺവേർട്ട് ഇൻ ടു ഐസ്. അതൊരു ഗ്രാഫിക്കലി നമ്മൾ എങ്ങനെ റെപ്രസെന്റ് ചെയ്യുന്നതാണ് ചോദിച്ചിരിക്കുന്നത്. വെരി ഗുഡ് സച്ചിൻ, യുവർ ആൻസർ ഇസ് കറക്റ്റ്. അത് മിസ് ഒരു ഗ്രാഫായിട്ട് ഇഫ് ഐ എം റെപ്രസെന്റിങ്, which one will be the correct representation? Which one will be the correct representation? Yes, yes, Bindu, Devika, your answer is correct. Yes, very good. Ellavarum unanimously they are saying option A and your answer is correct. Let's check in detail why option A is correct. Okay, yes. Ipo starting ഇതായിരുന്നു അതിന്റെ ടെമ്പറേച്ചർ ഫ്രീസറിൽ വെക്കുന്ന സമയത്ത്. ഓക്കെ, യെസ് അൻവർ, യുവർ ലൈക്ക് അമാൻ അൻവർ, യുവർ ആൻസർ ഇസ് കറക്റ്റ്. ജ്യോതി, യുവർ ആൻസർ ഇസ് കറക്റ്റ്. യെസ്, ഓക്കെ. ഇനി നമ്മൾ ഫ്രീസറിൽ വെക്കുന്ന സമയത്ത് വാട്ട് ഹാപ്പൻസ്? ദ ടെമ്പറേച്ചർ സ്ലോലി ഡിക്രീസസ്. ഡിക്രീസ് ചെയ്ത് ഡിക്രീസ് ചെയ്ത് ഡിക്രീസ് ചെയ്ത് വാട്ടർ എന്ത് ചെയ്തു? ഇറ്റ് റീച്ച്ഡ് 0 ഡിഗ്രി സെൽഷ്യസ്. നോ, വാട്ട് ഇസ് ദ സ്പെഷ്യാലിറ്റി ഓഫ് 0 ഡിഗ്രി സെൽഷ്യസ്? യെസ് സന്ധ്യ, യുവർ ആൻസർ ഇസ് കറക്റ്റ്. യെസ്, 0 degree Celsius is the freezing point of water. Yes, hi. Yes, 0 degree Celsius is the freezing point of water. Water എന്ത് ചെയ്യാൻ തുടങ്ങും? അവർ ഫ്രീസ് ചെയ്യാൻ തുടങ്ങും. ആൻഡ് അവിടെ ഉള്ള എല്ലാ വാട്ടറും ഫ്രീസ് ചെയ്ത് ഐസ് ആവുന്നത് വരെ the temperature remains constant. Okay, the temperature remains constant. ഇനി എല്ലാ വാട്ടറും ഐസ് ആയിട്ട് കൺവേർട്ട് ആയി. ഓക്കെ, വാട്ടർ ഐസ് ആയിട്ട് കൺവേർട്ട് ആയി. എല്ലാം കൺവേർട്ട് ആയി കഴിഞ്ഞാൽ പിന്നെ സ്ലോലി ദ ടെമ്പറേച്ചർ ഡിക്രീസസ്. യെസ്, വെരി ഗുഡ്, വെരി ഗുഡ്. യെസ്, ഓക്കെ. ഇസ് ഇറ്റ് ക്ലിയർ? Is it clear? So the correct answer is option A. All right, yes. Let's see the next question. Okay, we have two more questions. Okay, yes. Suggest which of the vessels A, B, C or D in figure will have the highest rate of evaporation. Explain. Okay, ഏതിനാണ് ഏറ്റവും ഫാസ്റ്റ് ആയിട്ട് ഇവാപറേറ്റ് ചെയ്യുക? Is it option A, B, C or D? Which vessel evaporates faster? Let me see the answers. Is it A? Highest rate of evaporation ആണ് ചോദിച്ചിരിക്കുന്നത്. Evaporation ഏറ്റവും കൂടുതൽ ആർക്കായിരിക്കും? Yes, mixed answers. Okay, I can see all the options here. I can see A, B, C, D, but majority is saying C. Majority says C. Okay, all right. Yes. B നോക്ക്, നമുക്ക് ഓരോന്നോരോന്നായിട്ട് കൺസിഡർ ചെയ്യാം. First consider B. നമുക്കറിയാം evaporation increases with increase in surface area. Yes, Sachin, you're correct. Yes, Nivedita, Devika. Yes, I can see your answers. Okay, you're all correct. ഇനി സർഫസ് ഏരിയ ഇൻക്രീസ് ചെയ്യുമ്പോൾ ഇവാപറേഷൻ ഇൻക്രീസസ്. അപ്പോൾ റൈറ്റ് അവേ വി ക്യാൻ ക്യാൻസൽ ഔട്ട് ബി. ഓക്കെ, ബി ക്യാൻസൽ ചെയ്യാം. വൈ? ബിക്കോസ് ഇറ്റ് സർഫസ് ഏരിയ ഇസ് ലെസ്. ഇനി നമുക്ക് ആരാളുള്ളത്? വി ഹാവ് എ, സി ആൻഡ് ഡി. ഡി എന്താ? ഡി കവർ ചെയ്ത് വെച്ചേക്കുക. Okay, evaporate ചെയ്ത് പോണ്ടേ, പക്ഷെ it is covered. So നമുക്ക് എന്ത് ചെയ്യാം, D നെ അങ്ങ് കളയാം. ഇനി നമുക്ക് ആരാളുള്ളത്? We have option. We are left with option A and option C. Yes. C എന്താ? C യുടെ തൊട്ടുമുള്ള ആരുണ്ട്? We have a fan here. Fan ഇങ്ങനെ കറങ്ങിക്കൊണ്ടിരിക്കുക. So, surface area വലുതാണ്. അതോടൊപ്പം തന്നെ എന്താ? Wind speed അല്ലേ? Windന്റെ speed increase ചെയ്യുന്നതിനനുസരിച്ച് the evaporation will increase. Okay. So, it is option C. Okay. It's not A. It's option C. Option C will have higher rate of evaporation. Is it clear? Clear alle? Easy alle? Ipo manasilayile? Yes. You are correct, Nivedita. Yes. Shall we see the next question? You are familiar with this question, I'm sure. Here, name A, B, C, D, E and F in the following diagrams. Okay, first let's start with A. What is actually happening here? We have solid, we have liquid and we have gas. Okay, left to right, we are increasing the temperature and decreasing the pressure. Okay, right to left, decreasing the temperature and increasing the pressure. Now, what is option A? Solid gets converted into liquid and that process is called? Very good. A is nothing but it is fusion. Okay, solid liquid aayittu convert cheyana, it is fusion. Now, what about B? What happens in B? Here, liquid is converting into gas. Liquid converts into gas. Our process is very good. The process of converting a liquid into gas is called what? It is called vaporization. Very good. Vaporization. Perfect. Now what about C? What about C? C, what happens in C? The gas is getting converted into liquid. Gas is getting converted into liquid. That process is called what? Very good. It is condensation. It is condensation. So, we are done with A, we are done with B, C and now D. What is D? D. Here liquid is converting into solid. Very good. It is solidification. It is solidification. Okay. Alright. Yes. Now, what about E? Solid is directly getting converted into gas. What is that process called? Very good. It is called sublimation. It is called sublimation. And last but not the least, what is F? What is F? Here gas is getting directly converted into solid. Perfect. It is deposition. Very good. So, you are thorough with the processes, right? Perfect. Now, let's move on to the last question. Okay. It's the last question. It is a case study, a paragraph-based question. Okay. So, read the paragraph carefully and then you should answer the questions. Okay. Yes. Alright. So, the phenomenon of change of liquid into vapor at any temperature below its boiling point is called what? Yes, Anjali teacher is not here, okay? She'll come with another interesting after class. Don't worry, okay? Perfect. Yes. So the phenomenon of change of liquid into vapors at any temperature below its boiling point is called evaporation. Below its boiling point, that's an important sentence, okay? Below its boiling point. Okay, yes. The rate of evaporation increases with increase in surface area. Okay. It increases with increase in surface area, temperature, speed of wind and decrease in humidity. Okay. We already discussed this. Now, evaporation can cause cooling. Why? Because due to the decrease in average kinetic energy of the remaining liquid after the surface molecules leave. Okay. Lower the boiling point of the liquid, higher is the rate of evaporation. Boiling point koravaയിട്ടുള്ള liquids പെട്ടെന്ന് evaporate ചെയ്യും. Okay. ഇതാണ് നമ്മുടെ paragraph. Now, I'm fine. Yes. Now, let's answer the questions. First question. Synthetic clothes are uncomfortable in summer because, here you have the options. They absorb kinetic energy from air molecules. They do not let the sweat to evaporate. They are highly porous. All of the above. What do you think the correct answer is? What is the correct answer? Let me see who is the first one to answer. Mixed responses. Option B, option D. But majority is saying B. The correct answer is option B. Okay, option B. Why? Synthetic clothes, they are not porous. Okay, they porous alla. Okay, they will not absorb sweat. Sweat ne absorb edittu, they will not allow them to evaporate. Okay, they absorb illa, they evaporate cheyan sammayikkilla. So what is the best option for summers? It is to use cotton clothes. Okay, cotton porous aanu, they absorb sweat and they will what? Easy evaporation. They will make evaporation faster. So the correct option is option B. Yes, very good, very good. Now let's see the second question. Why liquids like ether and acetone are kept in cool places? Oh, that's the answer. Why liquids like ether and acetone are kept in cool places? What do you think the answer will be? Okay. Very good. Because they evaporate easily. Ether acetone, they have very low boiling point. Okay. Our boiling point valare koravanu. Nammal paragraph il kandille. Low boiling point aanengil they will get evaporate fast. Appo room temperature lokke vechalum they will what? They will like evaporate very fast. Appo nammal evada store cheyanam? We should store them in a cool place. Okay. Yes, cool place la store cheyanillengil they will evaporate faster. Okay. All right. Okay. Now third question. Yes. Water spilled on the floor evaporates faster than water in glass. Explain why. This is an easy question. This is an easy question. Floor spread aayittulla water evaporates easily than compared to the glass in a very good. Floorless spill the water will have what? It will have higher surface area compared to the water in the glass, right? So if surface area increases, what will happen? Surface area increase cheyumbo evaporation increases. Okay? Is it clear? Water spilled on the floor surface area എന്തായിരിക്കും അവരുടെ? The surface area will be higher. Okay, hence the rate of evaporation also increases. Yes, very good, very good. Now, the last question for today is, you want to wear your favorite shirt to a party. നിങ്ങൾക്ക് ഒരു പാർട്ടിക്ക് പോകണം and you want to wear your favorite t-shirt. But the problem is, it is still wet. Okay, നിങ്ങൾ സ്കൂളിൽ പോകുമ്പോൾ യൂണിഫോമിനൊക്കെ സെയിം അവസ്ഥയായിരിക്കും അല്ലേ? It is still wet. Mention any 3 steps with reason that you would take to dry it faster. You will put it under fan. Okay, yes, why? Yes, you're right, Aman. Fan adiyil vekkum. Why? Wind speed increases evaporation, alle? Yes, you will use fan then. Any other answers? You will iron it. Iron cheyum. Why? Iron cheyumbo temperature increases. Temperature increase cheyumbo what happens? Evaporation will increase. Pinandi, you will spread the shirt on a stand. Yes, you will spread it out. What happened? What happened when you do that? Surface area increases. Okay, surface area increases. Yes, and you can also squeeze it. Okay, squeezing, but what will happen? Some moisture is given out. Okay, and you can also keep it under fan. Okay, under a fan. Okay, you have a lot of options, guys. Yes. So, is it clear? We discussed the questions. Okay, clear? You were all answering and I'm so happy. Okay. Alright. So, thank you so much for joining. Okay. Now, ellarkum bye-bye. I look like your English school teacher, really. Okay. Nice. All right. So, ellarum India. Okay. So, good night, everyone. Bye-bye. Yes, bye.